Hello, thank you so much to listening to my movie pitch idea. I know that this isn't exactly the typical kind of movie pitch that you listen to, but I really appreciate you spending time to listen to this. So the movie I was thinking is called Connectivity Preserving Coordination Control of Multi-Agent Systems with Time Varying Delays. I know that's a little wordy, but I figure if we give it a nice subtitle, viewers will be more interested in it. So I was thinking something along the lines of not the solution multi-agent systems serve, but the one they need. Pretty sure that one hasn't been used before. So we open on the deep narrator voice saying, in a world where time delayed computer communication prevents direct and immediate access to nearby information, interagent coupling has been distorted. Synchronization is in greater danger than ever before. One man can save us all. Euler. I'm sorry. You don't know Euler. Well, I will give you background, but I'm sure our viewers will be very well familiar. But just for your background, a agent system is a computer program that can act autonomously after the user programs it. And so these are quite sophisticated programs and they have been used to solve many complex problems. Now a multi-agent system is several of those agents combined. And having multiple of the agents increases the data that it can use, it increases the computing power that it has, and thus we can solve even more complex problems with it. So if you think about the agent system as a one state area, then the multi-agent system is a tri-state area. And see how those are connected? You got that? All right, excellent, excellent. So our problem is that the communication between the agents leads to some time delays between them, and agents can't access the nearby information. This leads to a lot of disturbances in the gradient-based controls, and the agents suffer instability. We don't want that, so yeah, back to the most exciting ad. From the very prestigious members of the IEEE comes the film that critics call very detailed and innovative use of a classic law and thorough in its preliminaries. Then we open on a girl, because diversity, very independent young woman, who shows up and she's all like, guys, we need to find a way to combine the proportional control with an injected damping term, represented here, proportional control and the damping term. It's the only way to overturn the disturbances from the delay signals, represented here. And of course, the evil men in her life come and are just like, no, can't do that. And then the town crazy comes and vouches for her, and she's all like, well, it could work if you use a dynamic filter to inject the damping indirectly to the multi-agent system and directly in the Euler language network, represented dynamic filter, multi-agent system, and the Euler language network. And I will go over those for you because movie executive, I know that you're very busy and don't have time to look all this stuff up for yourself. So delayed signals are just what naturally occurs when a computer has multiple inputs going into it. Due to the nature of transporting this data, that we need to have time delays to be able to have the computer run effectively. Without proper measures, this can lead to instability. Portion control is a type of linear feedback control system, and it controls a variable by changing it proportionally to the difference between the set point, the desired value, and the measured value, the process value. The damping term is what influences an oscillatory system, and it stops a system from oscillating. The dynamic filter is a flexible and powerful filter that is autonomously conditioned on a single output. Euler language network is a kind of programming language that is a dynamic type. So that means that it searches for errors during the runtime, and it allows for a lot more inputs, like in addition to traditional numeric, logical constants, arrays, undefined types, all of those lovely things. Multi-agent system, we already explained before, it's a network of loosely connected software agents. We already went over that. So to summarize, proportional control controls the dynamic filter, which then controls the damping term, which directly influences the Euler language network and indirectly influences the multi-agent system. And all of that solves the problem of delayed signals. All right, so back to our ad. For one problem, our heroes will have to create 5 propositions, 2 theorems, and 2 simulations. And then we end it with explosions everywhere. And of course, now because viewers will be so into this that we will need to warn them that this movie will be coming soon in roughly 6 months from never. And cut.